If you've ever worked in a warehouse, you've probably had this moment. The system sends someone across the building to pick an item, and everyone wonders why. The workers don't know, the supervisor doesn't know, sometimes even the engineers don't know. The reasoning is hidden inside an optimization system. Today, I'm going to show you a simple way to make a warehouse system an explainable AI system, not a black box. The architecture that makes this possible is called an emergent state machine. But we're not going to start with the architecture. We're going to start by how the system makes us feel. Imagine you're a warehouse worker and you get this message on your device. When you click Y, a message pops up with an explanation for this pick. You are near aisle 12, and there are several same-day items in this area. Picking this item now helps ship those orders faster. So now, instead of simply issuing commands, the device is able to give you an explanation. Let's take a look under the hood at the ESM architecture that makes the Y button possible. In a traditional system, the operation goes something like this. The system moves from state to state to state as events happen. A scanner fires. Inventory updates. A task gets assigned. And the system just keeps evolving its state. But the reasoning behind those transitions is usually hidden. An emergent state machine works a little differently. Instead of jumping directly from state to state to state, every change passes through something we call a turn. A turn is a structured record of the decision that caused the state to change. A traditional system logs what happened. An ESM system records why it happened. The turn records how the decision was made. The worker in our example is operating in the state that decision produced. So now let's go back and look at the turn record that enabled the Y button. The system signals showed the worker was already in aisle 12, and there were 3 urgent picks nearby. The interpretation layer recognized that as a batch pick opportunity, and the policy decided that the next assignment should come from that batch. The worker now sees the result of that decision as their next pick. Now that the system can explain decisions, here's what that unlocks. Workers gain trust in the system. Supervisors can give their teams better explanations about how processes work and how decisions are made. All of that becomes possible because policies are explicit instead of hidden in code. Now, engineers close to the operation can adjust system behavior using direct observation and professional judgment. They can also get more out of optimization systems, because in ESM, we separate model behavior from policy behavior. And by now, you can probably see why that separation matters. To understand how these decisions work, we need to look at the building blocks the system reasons over. At this point, it would be fair to ask, where do the signals come from? The answer is simple. Warehouses already generate them. Scanner events, inventory systems, robot telemetry, order systems, task queues. These systems are constantly producing operational data that fit naturally into a turn-based architecture. In an ESM system, we normalize these signals into operational primitives. Simple, well-defined pieces of information that describe the current state of the warehouse. In ESM, we treat primitives as deterministic signals about what the system is observing. ESM then uses those primitives as the building blocks of decisions. So the primitives become the signals the system reasons over when making a decision. We've explored how this works with one turn, but warehouses aren't making one decision at a time, they're making thousands. So the next question is, what happens when we can see all of those decisions at once? Imagine running a warehouse like a traffic control tower. Today, many operational systems are a bit like a tower that can hear pilots talking, but can't see the radar. They hear events, they see outcomes, but they can't see how those decisions were made. To get started with ESM, the first step is simply recording the turns behind operational decisions. Nothing has to change about how the warehouse operates. Teams can begin learning about their systems just by recording turns and replaying decisions. ESM can function purely as a governance layer, as it does in this phase. And many teams may never need to do anything more with it. It's a bit like turning on the radar screen of the control tower. Once that reasoning is visible, some teams may want to explore how ESM could bring operational decisions under structured policy. At that point, the system is no longer just observing decisions, it's helping guide them. This is when the control tower actually starts directing traffic. In an emergent state machine, every operational decision has structure. Signals describe what the system observed. Interpretation describes what those signals mean. Policy determines what actions are allowed. That reasoning is recorded in a turn. Instead of observing a system evolve from state to state with no explanation, we can see the decisions that produced each change. At the level of a single worker, that means the system can explain why a pick was assigned. And at the level of the entire warehouse, it means we can see and coordinate thousands of decisions across the operation at once. That's what turns a black box into an explainable system. If you're curious about the architecture, the open source ESM specification and examples are available in the repository. Thank you for watching.